Right, hello guys. This is video number 3 of a series of video regarding the solution to a projectile motion that we come up with, but not always, not always. Two equations in two unknowns, and the best method to be used here is not the method I am developing. No, I'm sorry, but substitution. All you have to do is substitute equation number 1 to all that is in equation number 2. That is there. So this was your t, 15 over cosine of theta, or that is also 15 times the secant of theta. That's it for the square of t. Simplifying, now, you know naman that the sine of theta over cosine of theta is tangent of theta, while the square of the cosine of theta is secant of theta. So why did we wrote it that way? The reason is to avoid one of the most difficult type of expression to deal with, and that is rational, those with the fraction bars, so that you don't have fractions anymore in this particular equation. Then further, the problem is, how do we solve for theta? In this case, we only have one equation in theta, but we're dealing with trigonometric function. So naturally, our approach will be trigonometry. And don't ever forget the relationship between these two trigonometric functions. Alright, if you still can recall, that can be derived using the Pythagorean relation of the 6 trigonometric functions. One of which is this relationship between secant and the tangent functions. Alright, so let us substitute that therefore to the square of secant theta right there. This was originally secant square of theta, so that the function becomes purely in terms of the tangent of theta. And we are expecting something like a quadratic equation because of the presence of this second degree trigonometric function. Alright, so simplifying further, since we're expecting that, and to deal with quadratic functions, your coefficient of the second degree term must be 1. That's the reason why I am going to divide everything by this particular expression coming from there. You can actually do it in your way without dividing everything by this particular expression. But for me, it can easily be the quadratic equation can easily be processed if your a, which is the term, as the coefficient of the first term is 1. All right, that's it. Then the result, that is 2000 divided by our denominator, which is 16.1 times the square of 15. The result is 0.552. Kindly check. While 800 times 15 divided by the same denominator is 3.313. And of course, this one divided by itself is now equal to 1. All right, removing the grouping symbol, that's going to be the result, which is actually quadratic equation. Simplifying further. Alright, so that's it. We need to conform that into the so-called standard form. The quadratic equation in standard form. That's it. We have the values of a, b, and c into the quadratic formula. So take note, our x there is the tangent of theta. There. Because the square of x is the square of tangent of theta. Pretty obvious, right? And then calculator will give us two values for the tangent of theta. So taking the arctan of both, we have two values for the launching angle, and either of the two will be able to hit the target at point B. Thank you very much.